Hello and welcome everyone to another episode of vBrownBag. I am here tonight with Tyler Hatton to continue our Certified Kubernetes series where we are covering the major domains of the exam. Tonight we're going to be talking about cluster configuration. Tyler, welcome to the show. Tyler and I were actually colleagues at Worldwide Technology previously. And Tyler is an automation guru. If you're not aware of Tyler, I actually remember Tyler. I remember listening to you talk about documentation as code, and that inspired me to start writing some Sphinx CI/CD to like take the comments of my Python code and publish that to a web server. And like I was super inspired after you did that talk. So I'm like, I've really got to look into the Sphinx thing. So Tyler, automation guru, focuses a lot on assisting traditional IT organizations adopt SRE and DevOps principles. He also holds the CKA, the CKAD, and the CKS certifications. So you are in amazing hands for this talk. So that's a little bit overview of the show. Again, we are hosting a CKA series here for all of you who are hoping to take the CKA exam. I myself am hopefully going to try and do that as well. Hopefully, fingers crossed this year. Yeah, really looking forward to this conversation. If you want to get in on the conversation, you can on Twitter by adding vBrownBag or adding the hashtag vBrownBag. I'll be monitoring Twitter. If you're in the show, you can always post it in our question and answer panel in Zoom, and I'll be watching that as well. And make sure to follow Tyler on Twitter at TLRHTN, Tyler Hatton, and you can follow me at Cloud Osmotic. And with that, I will hand it over to you, Tyler.
Perfect. Thank you. Thank you very much. And thanks for everybody for coming tonight. Let me share my screen really quick and you can yell at me if you don't see it. I would assume everybody can see it right now. All right. Perfect. So
Yes, we can see it.
welcome to week 3, everybody. So for the first 2 weeks, we've kind of basically covered the basics of Kubernetes. What are the different components? And then we walked a little bit through kind of the installation of Kubernetes. What does that look like with a tool called kubeadm? And now we're finally, I think, to the exciting stuff, which is cluster configurations. So what we're going to cover just at a very high level is what are kind of the important concepts that you need to know for the CKA exam in order to be successful in configuring your cluster. What are the commands you need to know, specifically when it comes to kubectl, what's kind of the magic behind that, and then kind of going into a little bit about, how can you change and tweak different components of your overall cluster. If this will let me switch slides. Hold on really quick. There we go. See, I told you there'd be a technical difficulty. No, but as mentioned, my name is Tyler Hatton. I'm a solutions engineer at F5 Networks. If you're unfamiliar with F5, I would assume most people are at this point in time, but if you're not, we're an application delivery networking company. Probably most well known for selling our load balancing solutions, but we have a ton of integrations when it comes to Kubernetes. Certainly not the focus for tonight, but if you ever have any questions around F5 and Kubernetes and how all those different things come together, seriously, reach out to me. Always happy to talk to you about it. Certainly have a lot of experience bringing those two things together. Based out of the St. Louis area, kind of born in the area, raised, happy to live here, that sort of thing. And then as of mentioned, I do have the CKA, CKAD, and CKS certifications. I would like to think that makes me an expert in Kubernetes, but candidly, I probably know just as much as you, or maybe a little bit more, but I'm not an expert. I know enough to be successful, certainly managing a cluster and taking these exams, as has been validated by me taking them. But that being said, in all honesty, I put my LinkedIn and my email on here and my GitHub profile if that's something you want to see. If you want to reach out to me, or if you have any questions at any time about the Kubernetes exam, or just curious what the experience is about, or maybe you're worried about it and need a confidence boost, or just want some quick tips and tricks, always happy to talk to you about that. I know these certifications, or at least these 3 exams, pretty well. I love them. I thought they were some of the best certifications I've taken. They're kind of the perfect balance of practical skills and challenge. It is a practical exam, as been talked about in previous weeks. So certainly love to talk about the exams with other people and kind of my own perspective on those certs and how you can be successful in taking them. So kind of going into the overall content for tonight and high level agenda, I'm coming into this really with three different personal objectives that I want to achieve, at least for folks that are watching, week 3 of this process. And the first objective that I really want to cover is looking at the first section of the CK syllabus, which you see on the right-hand side. It's on GitHub, and you can download this from the CNCF if you're curious. But looking at this first section around cluster architecture and installation and configuration, and kind of covering the sections I don't think we've touched on yet. So things like RBAC and cluster upgrades, we'll certainly cover that in a couple minutes. So look forward to that. The second objective I'm kind of looking to at least achieve today at a very, very high level is covering the concepts that I think are important to take the CKA, but aren't necessarily mentioned in the syllabus. So that's kind of where namespaces come into play. So we'll talk a little bit about namespaces. And then finally, what I'm really hoping to kind of cover tonight, which is really our main focus, is I want to make sure anybody who's kind of watching this section, they have the ability to be successful in the later sections. So that's kind of where the focus on kubectl will be a little bit later tonight. Is if you look at the next couple sections, we're going to be talking about scheduling workloads or containers within Kubernetes, storage, networking, and a lot of that is very kubectl or kubectl or kube, whatever the heck you want to call it, focused. So what I really want to cover tonight is kind of a final objective, is just giving you the confidence in knowing the basics of kubectl so you can go into the later weeks and apply those for performing all the configurations they'll talk about in those later weeks. So that's a goal. Our agenda again is on the left-hand side, and yeah, let's kind of kick things off. So before I actually go into the content, one thing that I want to call out, and the other folks have kind of talked about this in the previous weeks, which is what do they use for their lab environment? So I think last week was it Nathan had used a Raspberry Pi or Raspberry Pi cluster, I think, for his Kubernetes lab environment. And I think before that, David, I think, used maybe a VM that he was running. I don't know if it was on top of VSXi or something else, but I think it was a VM that he already had set up with Kubernetes. And for me, I do some things a little bit different. So I am notoriously cheap and impatient. So I want my Kubernetes cluster now. I don't want to waste time setting it up, and I don't want to pay for it. And a good solution for that is this thing called Catacota. So what Catacota is it's basically free on-demand Kubernetes environments that you can launch by going to this catacota.com website. Don't let the O'Reilly name intimidate you. They bought them like a year ago, but it's the same site it was a year ago for the most part. But you can sign up for a free account, launch an on-demand lab, start running kubectl commands almost immediately. So like this is an example of a lab environment that we'll be using a little bit later on. And I launched this like within seconds. I'm not even exaggerating. But you can launch a similar environment and again, kind of get your feet wet with Kubernetes. And if there's a certain command you just want to test in a hurry, Catacota is a fantastic resource for that. And then the final thing I'll just kind of mention around Catacota, and I promise I'm not like trying to sell this to sell it. What you will see in the Kubernetes documentation in certain sections is this interactive tutorial link or interactive tutorial button. And what that button sends you to is Catacota. So there's sections of the Kubernetes documentation that specifically point you to Catacota. So this isn't like just some random thing that I'm recommending people use. The Kubernetes documentation points you to Catacota. So great resource that frankly saves you a ton of time for setting up an EKS or a Minikube or a Raspberry Pi cluster. You don't have to do any of that. You can literally just launch a lab inside of Catacota and hit the ground running. It certainly won't give you everything that you'll need probably to test out every part of or every section you need for the exam, but it certainly gives you most of the resources you need to get started. All righty.
That's excellent. Yeah, thanks, Tyler. That's interesting. I remember Catacota before, so O'Reilly purchased them then. And is this so people would just go to O'Reilly.com, or is there a link you can provide? I guess we could.
It
If
is.
you have a link, I could put that in the show notes later. That'd be great. You don't have to give it to us now.
Hold on really quick. There we go. I somehow turned on subtitles or something. Anyways, it's catacota.com. Like
Oh,
that's what it is.
yes, it's
Like,
right there in front of me. Sorry.
no,
Okay.
it is no secret. It is very easy to find.
Yes.
And yeah, it's a great resource. And the one final thing I'll mention too. So in the past couple of weeks, people have mentioned like Coopctl or the class that Moonshot does that's on Udemy. That, or at least it used to, and I think it still does. It runs on Catacota also. So like it's
Interesting.
funny. Like you're gonna be using Catacota probably at some point, whether you like it or not.
Interesting. Yeah, I've been using Coopctl actually. It's great, great material as well. So I'd be interested to see Catacota as well. So
Yep, absolutely. Yeah, and Coopctl, I'll talk about resources at the end, but that was probably my favorite study resource for the CKA. By far the most expansive in the content that it covered, put it that way. So great resource. But this is what I use for labs, and this is what I'm going to use for labs for the rest of the night. So if you don't like Catacota, well, you're out of luck. But anyways, kind of going to the actual content of what we're going to talk about tonight. And it as somewhat of a review into kind of the first week and what was covered from a Kubernetes architecture standpoint. What we had talked about during the first week was kind of this idea of a master node and a worker node. And if we remember kind of going back to that first week, what we had talked about was the master node was kind of the control plane piece of our Kubernetes cluster. It was kind of the brain. It handled all or most of the operations that were occurring on our cluster. It was kind of the big puppet master that was kind of controlling everything for the most part. And then we had talked a little bit about worker nodes, so the nodes that are basically handling the containers or resources or compute resources that we're going to be running within our Kubernetes cluster from a day-to-day standpoint. But when we talk about this thing called kubectl, which is going to be the first focus of tonight, what this is primarily focused on is it's a CLI command that runs on our local machine, or we could run it in like a CI/CD pipeline if we want to. And the way that kubectl works is it basically interacts with our master node through the API server. And just as a review for the API server, as the name suggests, it's, I kind of view it as almost like the exchange or like switching board of your Kubernetes cluster. Most of the messaging between the different components usually go through the API server from a communication standpoint. And kubectl, this command that we're going to be using a lot of tonight, uses that same API server to get data about our cluster, but also perform configurations on our cluster behind the scenes. So again, kind of a high level architectural review through a simplified diagram of what we're going to talk about. But when we look at this diagram, something to call out, and we'll show an example of a kubectl or kubectl command in just a second. We have to figure out how the heck does this kubectl command know where to go. So if I go to my command line interface right here, and let me know if this is too small. Let me try to make it a little bit bigger. I was struggling with this earlier today. Can I make this bigger? Come on, you can do it. Is it Control Shift? There we go. All right. As you can see, I'm amusing myself with my own technical difficulties. But what I'm going to do is I'm going to run a kubectl version. And this is a super basic kubectl or kubectl command that you can run to kind of test your connectivity with your cluster, or at least with the API server in your cluster. And when I run this, it's going to give me two different things. It's going to give me the version of the kubectl client that I'm using. So in this case, it's major version 1 and then minor version 18, so 1.18. But it also gives me the version of my cluster, which is also 1.18. But you look at this and you have to ask yourself, how did kubectl know where to go? Like nowhere in here am I saying kubectl go to this API server or go to this IP and port combination. Where is that being configured? How is it figuring that out? And that goes to kind of our first important concept when it comes to using this kubectl or kubectl command or whatever the heck you want to call it. As you can see, I call it everything because I like making everybody upset in how I pronounce words. But How kubectl or kubectl figures this out is through this thing called the kubectl file, or through what's called our kubeconfig. And what the kubeconfig file is about is it's basically a file that sits on our file system that defines the what and the who. So what server we want to connect to, the API server we want to connect to, and the who we want to authenticate to from a Kubernetes cluster standpoint. So if I were to go into my lab environment, I would find this file in this home directory.kubeconfig location right here. And just something to call out is you can also customize the location of this file if you want to. You can do it through like an environment variable or directly when you run the kubectl command. But by default, it will be in this location. And it probably will be in this location when you do the exam. Hopefully that's not breaking NDA by saying that. I don't think it is. But when you look at this kubeconfig file, the way that kubectl figures out where to go is inside this kubectl command, there's 3 different sections. There's a cluster section that basically defines the where do you want to connect to? In this case, it's this 172 address over port 6443. That's our API server. The port for our API server is usually going to be 6443. We define the users or user that we want to connect as. And in this case, we have this thing called Kubernetes admin. And we, in this case, have a certificate and key that we're going to use for our authentication. But you can also use basic auth if you want to. Certificates are generally more secure. And then finally, within our kubeconfig, we have our context. And we'll see a little bit of this later by showing it our different contexts. But what a context is, in the case of Kubernetes, is it's a combination of our cluster and our user. So if we look right here, we're referencing a cluster. What cluster? Kubernetes, which we see up here. And then if we look down here, what user are we going to authenticate into our Kubernetes cluster as? We're going to authenticate as this Kubernetes admin user. So that's how it kind of brings all these things together. And that's how it's able to figure out when you run kubectl or kubectl where to go. Basic concept, but again, I'll say for the exam, it's something to kind of at least understand at a very high level, because at the end of the day, you're going to be running a whole bunch of kubectl commands when you take the exam. And you might be thinking to yourself, how the heck is all this stuff working behind the scenes? And this is kind of how it's figuring things out for you and where to go. But just some kind of quick commands to know when interfacing with these different kubeconfigs. So there's really kind of 3 of them that I would encourage you to get familiar with. And these are within the Kubernetes documentation and on this cheat sheet that I believe was brought up last week also. So if you haven't bookmarked this page, it is great. It provides a ton of different commands from a Kubernetes standpoint that you should be familiar with. But the first command that you might want to be familiar with is this kubectl config get context. So I'm going to run this right here and we'll see what it gives us. And actually, I'm going to clear my line because I might run into problems if I don't. So I'm going to do a kubectl config. And something I want to kind of point out when I run this is I'm actually doing tab completion. So I can't remember if it's enabled by default within the exam environment. But one of the things that cheat sheet gives you is the ability to enable tab completion through a command. So if it isn't enabled on the exam, you can use a cheat sheet to give you the ability to enable auto completion. It saves you a ton of time when trying to run these different commands. But when I run kubectl config get context, what it's going to give me is basically the list of context. So that combination of cluster, IP, and username that I'm going to authenticate for what I'm connecting to from a kubectl standpoint. And if you're ever curious which context you're using at any time, you'll also have this current section or this current column right here and a star next to the current context that you're currently using. So that's something else to kind of call out from an interaction standpoint. And then the second command that I would at least be familiar with for even CKAD or just managing Kubernetes environments in general is this kubectl config view. And what this gives you is basically that YAML version of the config that's on our system right now. So this looks very similar to what we just saw a second ago, but an easy way to kind of view that file is just running kubectl config view. And then finally, just a really quick command is kubectl config and then use context. And what this does is this allows you to switch from one context to another, or one cluster to another. So let's say, for example, you have like a dev test environment set up and you have different contexts for each environment. This is one way to easily switch between those different contexts. So in my case, I only have one, so I don't have to do any switching, but that's how you would do it. But calling those out really quickly, again, it's just at the end of the day, you might be running kubectl. You already have this pre-provisioned environment. You might be thinking to yourself, how the heck is it figuring out where to go? It's all in that kubeconfig file. That's how it works behind the scenes. But kind of moving forward, once we have our kubeconfig file configured, the next thing that we can do within our Kubernetes environment is actually performing configurations or getting data about our environment. And if you're brand new to kubectl or kubectl, all your commands, of course, are going to start with this kubectl command. And then what you're going to provide it is some type of verb. So you're going to tell it, what the heck do you want to do? Do you want to get something? Do you want to apply something? Do you want to make a change or create something new? Do you want to edit something that already exists? Do you want to describe something that already exists? The whole point around kubectl, right, is it's kubectl and then the verb for that thing, again, that you want to do, and then whatever you want to edit. And we'll see some examples of this in just a second. But if we go to our command line window right here, let's run a quick example of one of these kubectl or kubectl commands, again, using tab completion to make things a little bit easier. So one of the things I can check is if I run like get, one of the objects I can look for, and if you want a full list, by the way, you can also do like a tab, and it lists all the resources that you have access to, which is kind of cool. That's the other thing that tab completion gives you. But if I hold on real quick. There we go. I lost my cursor. But if I do a kubectl get nodes, what this will do is, just from a basic command standpoint, is it will list out all the different nodes that are currently assigned to my cluster right now. So in my case, I'm only running a really basic 2-node cluster inside of this Catacota environment. We can view a little bit of information about this. So things like the status, which could be important when it comes to like troubleshooting. If this thing isn't in a ready state, it's probably broken. So you might want to take a closer look at it. Other things you can look at, like role, like maybe you want to know where are the master nodes within my cluster. Well, you can see that by looking at the role, and I can see this control plane node is my master node, and then this node 01 doesn't have anything assigned to it, so it's not my master. And then I can also see what version of Kubernetes these nodes are running. So this could be useful like when you're performing an upgrade across your cluster. The way that you would typically do upgrades is you're going to do it node by node. And as you go through those different nodes, it kind of helps to know which nodes are running the new version and which ones are running the old version. So you can see that here also. But again, just different information that you can pull using this kubectl command. And then kind of another one that I'll call out is describe, which I have at the bottom right here. And what describe does is it basically pulls additional information about a specific object that you have configured in your Kubernetes cluster. So in this case, I can do a kubectl describe. What do I want to describe? I want to describe a node. And what node do I want to describe? I don't know, control plane. And I'm using, again, tab completion to save me a lot of time in filling this out. But when I hit enter here, what it's going to do is basically give me a description of this node and the operating system it runs and how much CPU is assigned to it and memory. But an important thing I would kind of point out here, and again, we'll probably cover this a little bit deeper in the troubleshooting section later on. An important thing when you do a describe is you can actually see events that have occurred for this object. So let's say, for example, we were running into an error and maybe our nodes was in a not ready state. One way that you could figure out what's going on behind the scenes with that node when we do this describe command is just by looking at the events. There will probably be some pretty obvious errors in here if something is broken. So just kind of calling that out is just some quick commands that you can run to at least get more information about different components of your cluster. So I'm going to clear my line there. And then we'll look at a couple of these other commands a little bit later on. But again, all these commands, for the most part, follow the same pattern: kubectl, and then some type of verb, and then the arguments for that verb. And it honestly makes things pretty straightforward when you have to figure out, how do I configure a pod versus how do I configure an ingress? It all kind of follows that same pattern, as you'll see in the next couple of weeks. Go. So the next important thing to kind of understand with kubectl or kubectl is this idea of a manifest. And what a manifest is at a super high level is it's a YAML file that basically describes a resource that we want to create or modify inside of our Kubernetes cluster. So what you see on the left-hand side is an example of a Kubernetes manifest. And if you don't like YAML, boy, are you in for a treat, because there is a ton of YAML inside of Kubernetes. You have to live with it. I'm sorry. It's honestly, it's probably the thing that people complain about the most when it comes to Kubernetes is all the YAML that's involved with it. But if we look on the left-hand side, again, this is our manifest, an example of a manifest. And ultimately, when you look at this manifest, at least for this one, you can break it down into 3 different sections. The first section is basically this resource type section. And what this is about is basically telling Kubernetes through this manifest, what type of resource do we want to create? And there's usually always going to be 2 different values that you're going to provide. The API version, so what part of the Kubernetes API do you want to use to create this resource? And I'll be honest, for the API versions, you can almost always look those up in the Kubernetes documentation within the exam. But yeah, so if you're ever like, oh, for this type of kind, or what this type of resource, which API version do I use? Look it up in the documentation, look up that type of resource, and you'll probably find the API version assigned to it. That's honestly what I did when I took the exam. So that's the first thing that you need is the API version. And then the second thing that you need is basically, what the heck do you want to create? What kind of resource do you want to create? And in this case, we're creating this thing called a pod. And I'm not going to dig too deeply into what pods are and really kind of the intricacies of them, because I think that's going to be mostly up to next week. But at a very, very high level, what a pod is within Kubernetes is it's basically a container, or one or more very closely related containers that you want to run inside of your Kubernetes cluster. So when I tell Kubernetes the type of resource I want to create is a pod, I'm telling Kubernetes I want to run a container inside of my Kubernetes cluster. And then the second section that we have right here, in addition to our resource type information, is our metadata section. And as the name kind of suggests, they didn't just make this up to make it up, but as the name suggests, it's just metadata. It's information about information to describe this resource that we want to create. And most importantly, it has a name. So we probably want to create we probably want to give this resource some type of name. And that's how we do it. We do it through this metadata section. And we can give it additional labels if we want to, as we can see here. So in this case, maybe we give it the environment development, because it's going to run in our development environment. But that's not a requirement. You don't have to add that metadata if you don't want to, and you can add as much metadata if you want to also. Again, it's data describing data. And then the final section that we have, at least inside of this Kubernetes manifest, is the spec, or the specifications. And this basically describes how we want this pod, this resource, to interact, to perform inside of our Kubernetes environment. And that's what we see right here. So as I had mentioned, what a pod is it's basically a container, or one or more closely related containers. And if you know anything about containers come from these things that are called images. And that's what we're referencing right here. We're basically telling Kubernetes, hey, I need a container, and the image that I want to use to spawn this container is the Nginx image. And that's what we're doing right here through this manifest. So what I'm going to do really quick is let's go back to our lab environment, and let's just run this manifest really quick and just kind of show what this looks like. And I'm going to do this, or I'm going to create my manifest using a VI to do that. And one thing I would kind of call out is maybe a quick tip for the exam, because believe it or not, there are non-Linux people that take the Kubernetes exams. Get familiar with the command line editor. It's a requirement that they never really talk about. I'll put it that way. Get familiar with Nano or VI or whatever your text editor of choice is. I know there are certain people out there that are just unfamiliar and uncomfortable with using command line editors, but it's absolutely is a requirement for the Kubernetes exam. I'll just be blunt about it. But what I'm doing here is I'm basically creating this pod.yaml file. I'm going to write it to my file system. And then I'm going to, again, run another kubectl command, apply -f pod.yaml, and I'm going to hit enter. And what our kubectl command is going to do is, again, pull that file from the file system, look at the YAML contents of it, so the resource that we're describing, and then apply that configuration to our Kubernetes cluster, which we see here because it said it was created. Ain't that nice? But what we can do now is if I do a kubectl get pods or pod to list the pods that I'm running inside of my cluster, what we should see is we now have an Nginx container or Nginx pod running inside of our cluster. So, you know, a lot of when you take the exam is kind of this, or at least it should be this, you know, writing your manifests, applying them, and then maybe doing a get against it or a describe against it to make sure that it's running in the proper state. Honestly, you're not going to have a lot of time to take the exam. It's only 2 hours, and that seems like a lot of time, but honestly, a lot of it is like just applying some manifests and doing a quick check just to see if everything is running properly. That's kind of what you have to do just based on time constraints. But that's what we've done here. We've applied this manifest. And then one final thing I kind of want to do just really quick to kind of show one of the beautiful things about Kubernetes here is if I do a kubectl apply -f pod.yaml again, one of the things that it will do is it will tell me this is unchanged. And I think this is an important concept of Kubernetes, and that is this idea of idempotency. And what idempotency is, and it's this fancy word for a simple concept if you're unfamiliar with it. And it basically means before Kubernetes ever performs a configuration, it's going to look at that manifest and it's going to ask, hey, is what's described in this manifest, does it match what's in my Kubernetes cluster? If they match, it's not going to do anything, as we can see. It looked at the pod configuration. It saw, hey, on the cluster, it's the same configuration. I don't have to do anything. So that's why you see this unchanged statement right here. But what's really cool about this is you can use this to track configuration drift. So I can keep running this over and over and over again and continue to check, hey, is this configuration continuing to be in an unchanged state? And this can be potentially useful when you take the exam. It's certainly not a requirement to understand this concept, but it's something to kind of keep in mind, like what you might get yourself into a situation where you're like, did I apply that manifest? I know I wrote it, but I actually apply it. Well, you can apply it twice. And then the second time you apply it, hopefully it'll say unchanged. So just a quick tip when it comes to kubectl and applies and how that works. Cool. So that's manifest in a nutshell. And to be honest, you will see more manifests in the later sessions on more complex topics and more complex Kubernetes resources. But again, just to kind of give you a preview and an idea on how these work for something that's very simple like a pod. And then kind of going into this thing called namespaces. So I'm going to go back to my terminal session right here, and I want to run a command really quick. So I'm going to clear my line, and I'm just going to run kubectl get pods. And as we see right here, I only see one pod in this list, and that's the Nginx pod that I just deployed. However, this is not the only pod that's running inside of my Kubernetes environment. There are other pods that are running, specifically my control plane pods. So during the first week, we had talked about the scheduler, and earlier we talked about the API server. And on the second week, I think we talked about CNI, so the things that do the networking between our different nodes within our cluster. Where are all those different things? They're not here. Where are they? And that's where this concept of namespaces come into play. So when we connect to our Kubernetes environment using our kubectl file, one of the things that's being defined when we connect is a namespace. And what a namespace is at a very high level, there we go. I thought I lost my pen, but what a namespace is at a very high level is it's basically a way of kind of segmenting or dividing up the different resources that we are going to create inside of our Kubernetes environment. So if we kind of see right here, we have these different names like default and kube system and development. And these are all potential names of namespaces or different kind of labels or ways that we can divide up the resources that we provision inside of our Kubernetes environment. Common way that you could potentially set up namespaces, maybe you have different business units within your organization. Like maybe you have an HR namespace and an IT namespace and a warehouse namespace. You know, I'm coming up with this stuff. But again, just it's a way of dividing up these resources. That's the idea of a namespace. But the problem that we have when we connect to our cluster is ultimately, the content that we see when we do a kubectl command depends on which namespace we're currently in or that we currently have defined inside of our context when we connect to our Kubernetes cluster. And in order to see that context or that namespace that we're currently using, the way that we can see that is by doing that kubectl get context command again. So kubectl config get context. And you may have saw this earlier, but under this namespace column right here, we don't have a namespace defined. So we're not defining any type of namespace. So what Kubernetes is going to do by default is it's going to send our pods into the default namespace, which is, as the name suggests, the default namespace if you have no namespace defined. But again, that goes back to our mystery. Where are all those other pods for our control plane? And that's ultimately where kubesystem comes into play in most clusters. Whoops. So usually for most Kubernetes environments, most of your pods that are handling the control plane pieces are under this kubesystem namespace. So in order to see those different pods and to specifically view resources in another namespace, one of the ways that you can do that without like editing your context is I can run a kubectl get pods, and then I can add an additional flag -n and then name the namespace that I want to perform this command against. So in this case, kubesystem. And wouldn't you know it, there you go. There are all those different pods that were missing just a second ago. So again, I'm calling this out because it's an important concept to kind of think about for the exam and know about. When you run a kubectl get pods, you might not be seeing all the pods that are running inside your cluster. Again, these resources are being divided up in these different namespaces, and you need to have a way of viewing and applying configurations to those different namespaces. And then the one final thing I'll call out here too is you can also apply configs to a specific namespace. So if I do a kubectl apply -f pod.yaml, so that same nginx pod I had a second ago, and then do -n, let's say kubesystem. And you wouldn't want to do this on a production environment. But now what I've done here is I basically created that pod inside of my kubesystem namespace. So it's not just for pulling information about that namespace. It's also about applying changes to a specific namespace. I can do that also using that -n flag. And then the one final thing I'll kind of show here too is, let's say you get yourself into a situation where you want to see all the resources across all the different namespaces. So maybe you want to see all the pods across all the different namespaces. And there are situations where you might want to do that. Like an example I always think of is, one time I installed OpenShift and I was running into problems with it, but I wasn't sure all the different things OpenShift had configured behind the scenes through its magical installer that doesn't really tell you everything it does. And one way I did that is I listed out like all the different pods that were on the system to figure out what was running and what wasn't. But the way to do that is you can do a kubectl get pods, similar to this, and then a flag of -- all namespaces or -A. And as the name kind of suggests, it'll list out, in this case, all the pods for all the different namespaces. So just, again, another command flag when you're playing around with these namespaces to know. And then one final thing I'll just show here too is you can also list all the namespaces for that system too. So kubectl get namespaces, right? And hopefully what you can see here is there's a pattern. Get nodes, get namespaces, get pods. Luckily, they were smart about how they designed this kubectl command, where there's some patterns here where you can easily figure it out and kind of guess your way through performing configurations.
Yeah, that's a great overview of namespaces, and very interesting about the kubectl config piece, right? So if you're always working in a certain namespace, you could set your context to have that namespace as the default. And then every time you log into the cluster, you're automatically in, say, development or production or whatever. And you don't have to do a bunch of -n, when you're applying your things, you don't have to keep saying -n, you're just there.
Yeah, absolutely. It certainly saves you a lot of time. I'll say when I took the exam, and I don't think this breaks NDA, I did use a lot of -n to switch between namespaces. I think I can say that. I don't know what I can and can't say, but I did use a lot of -n because honestly, like, you don't want to get yourself in a situation where you're constantly modifying like the context or making changes where you don't have to, I guess. Try to
Right.
keep things as much in the same state as possible.
Right. I think, yeah, absolutely. I think if you were taking the exam, you'd probably want to use the namespace flag versus updating the kubeconfig file. But I think that's an interesting point, right? Like as a developer or something in a production or in an organization, maybe it's just easier to set your own namespace to go like so outside of the exam, right? If you're just a developer and you're working in this place or your team is working in this specific namespace, it may just be easier just to set your own namespace in the context
Yeah,
file. Yeah,
absolutely.
very interesting.
Yeah. And the other thing I'll just call it out in passing. I think it's still this. I think it's how it's still set up. So if you're using OpenShift, they call these projects. They call it something different. I think namespaces and projects are one and the same. Somebody who's an OpenShift expert could tell me otherwise, but they present themselves as largely the same. So something else to call out there. But in Kubernetes world, native Kubernetes, it's namespaces. So, finally, at least talking about kubectl or kubectl or whatever the heck we want to call it. Again, I keep calling it everything because that's just how I think. I like it because I know it upsets somebody. Anyways, we talked about these first two flags. So all namespaces and then dash in if you want to perform a configuration against a specific namespace or do a get against a specific namespace. But two other flags that I would kind of keep in mind are -o YAML and -o wide. And basically what these flags are about is dictating how you want a command to be outputted. So in the case of -o YAML, is it's probably suggested by the name, right? If I do a kubectl get pods or pod, it doesn't matter, both works. And then nginx and then -o YAML. One of the cool things that it gives me, and I used to use this quite a bit for like troubleshooting and kind of saving manifests before I started making changes to them. But I'm trying to find where I ran it. There we go. But when I ran this, basically what it's giving me is kind of a more detailed manifest that we saw earlier. So in addition to the actual configurations that we had in our manifest, it also shows us like the defaults that Kubernetes is going to put in here. There's also like state information in here. But again, what you can do is you can pipe this to a file, and you can certainly strip down the content and kind of get a backup of the current manifest that we're running on our device right now. So an example where you could potentially use this is got a Kubernetes cluster, you applied some manifest, but you lost a copy of the file. Maybe you need a copy of that file again. Well, you can do a get pods, the name of the pod, and then -o YAML to do that. So one kind of cool thing to run. I think I used that maybe once or twice on the exam. Again, I think I can share that. I don't know what I can and can't share. The other one that I would probably know is -o wide. So kubectl get node -o wide. And what this does, and let's actually do a comparison here, is it basically takes the normal get command that you would run. So it lists out the nodes, or it could be even pods, it could be anything, right? But adds some additional columns and details that might be useful for when you're managing your cluster or even taking the exam. So in addition to the version, what we have is also like the version of Docker that we're running, the operating system that we have on this system. So what distribution of Linux that we're running, things like that. All that's kind of contained in this -o wide. And the information you get kind of depends on the resource. So, it depends. But again, I'll say that there are certain situations where you might need to have this information, and it's a quick way to pull it is through that -o wide flag. I have to be very careful in what I say. I'm afraid they're going to take my certifications away. I work so hard for those. I don't want them to take them away. So that's kind of the basics of kubectl. The thing I will say again is in the next couple of weeks, you will see a ton of more examples on how to use kubectl to create a large variety of different resources. So if you're not comfortable with it now, you will be comfortable with it hopefully later on. And again, being comfortable with kubectl or kubectl is quite frankly probably one of the most important skills going into the CKAD, because most of the commands you're going to be running are going to be kubectl commands. So knowing how to run it, but run it fast, is an important skill to have. And through those Catacota labs or through Coopctl, you can certainly get a lot of that. But kind of going into really kind of the next section that I wanted to cover for tonight, RBAC, specifically around this concept of service accounts. So as you can imagine with Kubernetes, not everybody can be root, not everybody can be you and have admin access. So ultimately you have to figure out how the heck do we achieve least privilege when it comes to Kubernetes. And one of the ways that you can do that is through this concept of service accounts, roles, and role bindings. And what a service account is within Kubernetes is basically there are going to be certain situations where you're going to have a pod or a container that's running inside of your Kubernetes environment, and it needs to perform some type of authenticated API call to your API server or to your Kubernetes cluster to pull some information, maybe make a change. Maybe it's Jenkins and you want Jenkins running in Kubernetes, but you also want it to make changes to Kubernetes. That'd be crazy, but you can do that. But the way that you do that is through this thing called a service account. You're basically telling Kubernetes, I want to run this pod, but I want to run it as this user. And in this case, we want to run it as this user of test. So as I mentioned earlier, we have the spec section in our manifest. And as part of our spec, we can define a service account, which we're doing here. But to create a service account, honestly, it's one of the shortest manifests you can write within Kubernetes, usually. And to save a little bit of time, another verb that you can use to create a service account is using this verb called create. So you can say kubectl, create service account test, and that will create that service account super fast. And then you can reference it in your pod manifest. So quick shortcut, if you want to write the manifest for the test user, you could do that too. But again, it's like less than 5 lines in most cases to create that test user. It's certainly almost always less than 10. I'll put it that way. But ultimately, once you have that service account, you have to figure out, well, what do I want to give this service account the ability to do? Again, least privilege, it can't be root. Not everybody can be root. Not everybody can be admin. How do we give this service account that we're going to assign to this pod the least amount of privileges possible? And that's for this concept of roles and role bindings. And what a role is, and that's kind of the example manifest that we see at the very top. And as we can also see, follows the same exact patterns that we saw with the pod. There's a different API version, but you still have an API version in the kind. So similar patterns. And then we have some metadata right here, very similar to our pod, just to kind of call that out. But inside of this role that we're creating through this manifest, we have this rules section right here. And what the rules are basically about is it's basically telling Kubernetes 2 things. It's saying anybody that has this role, they have access to this resource. And in this case, it's the pod's resource that we want to give access to. And these are the type of verbs or commands that we can use when accessing these pods using this role. So in this case, we can do a get, we can do a watch, and we can do a list. But there's other verbs too, right? Like create, and I think update's one of them. And that stuff's in the Kubernetes documentation also. And there are tons of examples of roles, by the way. So if this is intimidating and confusing like it was for me when I took this exam, there are examples of this. So don't worry, there's a lot in the Kubernetes docs that you can reference when you take the exam. But we have a role here, and at the bottom we have our user. In this case, as I mentioned, this is how you create a service account using a manifest. It's less than 5 lines. It's super short. In this case, we're creating this user called Jane. But we need a way of bringing these 2 different things together. We have a role, we have our service account. How do we bring them together? How do we tell Kubernetes that we want to assign this role to the service account? And that's what a role binding is about. So that's kind of the center section right here. We're saying we have this role in our role reference. We call it pod reader, which gives our service account or anybody that has this role at the ability to read pods. And then we have a subject, which is basically our user, and our user is called Jane. And this is kind of the third thing that we would apply in our Kubernetes cluster. It's kind of the glue that brings those 2 different things together. So that's basic RBAC right there. It's a role binding, and if it's a pod, it's a service account. And And I think for the CK at the basic level, that's kind of what you need to know there is how do you apply these 3 different types of resources and kind of practice with those. But the one important thing to kind of call out and really know, and I'll be honest, this kind of confused me when I took the CK at first, because I don't know, I couldn't wrap my head around it, which is probably bad. It probably says what the type of person I am, which is sometimes not always the smartest. But for a role, it is basically limited to a single namespace. And what I mean by that is, I'm going to clear this out really quick. Oops, didn't mean to do that. But if I clear this out really quick, if we look right here for this role at the top, I'm actually in my metadata defining the namespace that I want this resource to be deployed in. And by the way, this is another way of dictating which namespace you want to use other than like -n. You can define it within the manifest. But in this case, I'm saying I want to have this deployed in the default namespace. And what this means is because I'm using a role, when I apply this configuration or this role binding to a user, they're only going to have access to pods inside of the default namespace. So something to keep in mind, roles are specifically for a single namespace or for the namespace that was created in. And then the reason why I bring this up is there's also this thing called a cluster role. So you got a role and a cluster role. I don't know, for some reason that confused me at first. And what a cluster role is it's basically a cluster-wide authorization to access a specific type of resource. So for me, the administrator, or maybe I want to create a new administrator or administrative service account, maybe I want to give it access to all the pods that are running inside of Kubernetes or inside my Kubernetes cluster. The way that I would do that is instead of a role, I would use this thing called a cluster role to do that. And the other thing to kind of call out about cluster roles is in addition to things like pods that are namespace specific, you also have resources that kind of supersede namespaces. They don't have a namespace assigned to them. And that's what you have with the nodes. So when we did a kubectl get nodes earlier, those nodes weren't assigned to a specific namespace. They're just part of the cluster. And in order to get access to information about nodes or any resources that don't have a namespace assigned to them, you have to use a cluster role to do that. And that's what we're doing here in at least this example on the left-hand side. So kind of follows the same sort of pattern that we saw with roles, except it's called cluster role and cluster role binding, where we're basically saying, hey, I want to provide access to nodes. What type of access? Get watch list. And then we have our user again, Jane. She's getting more and more access by the day. Lucky her. And then, and then we have this role binding in the middle that kind of brings it all together. So again, the big thing I'm just going to call out here is both these concepts work very similarly, but role, namespace specific, cluster role, cluster wide. And then for certain types of resources like nodes, you have to use a cluster role. And if that confuses you, again, Kubernetes documentation has examples of cluster roles, cluster role bindings, you name it. That is what I use for the exam, to pass the exam. I use that documentation, and honestly, you can use that too. So, just something to call out is just kind of cluster roles and roles. That's kind of how basic RBAC works behind the scenes. And then kind of the final topic for tonight. We have 5 minutes, and I will not go too much over time, I promise. So the final topic I wanted to cover was Kubernetes upgrades. So the good news about the exam is, and any lab that you work in, to be honest, when it comes to Kubernetes, is these are going to be probably blank or not production lab environments. I'll put it that way. They're not production environments. So you're not going to have a whole bunch of different Kubernetes workloads running on them, which makes doing upgrades, honestly, a lot easier than if it's like a production system, because there's a whole lot of variability when it comes to doing upgrades on a production system. However, I will say upgrades have improved significantly in Kubernetes over the years. But when we look at upgrades, the big thing to kind of keep in mind is, going back to what we kind of mentioned earlier, for every Kubernetes version, you're going to have a major version. There's only been 2 of those, 0 and 1. We're on 1 right now. A minor version, which they release one every 15 weeks, usually, or at least around every 15 weeks. However, There have been kind of longer waits, especially during COVID times, if I remember correctly, where it was certainly longer than 15 weeks between minor releases. And then you have a patch version, which is like hot fixes. They have a bug, they need to fix it. They put out a patch to fix it, and there you go. You've incremented it to .1. So just some quick things to kind of know about upgrades. And then the next thing, if you are managing Kubernetes or have plans on managing Kubernetes in a production environment, realize that at least as of 1.19, every minor release of Kubernetes has about a year of support associated with it. And what that means is the community, so the open source community, will support that minor release and provide patches for it if you run into a bug for about a year after that version is released. And that changed recently. I think it was like 9 months before that. So I guess be happy and unhappy. One of the realities if you're managing Kubernetes is you're going to be doing a lot of upgrades. It's honestly why a lot of people look at like a managed service like an EKS for their Kubernetes clusters, is it somewhat makes upgrades a little bit easier versus like doing it natively. But that's another gripe I've always heard about Kubernetes is I gotta do all these upgrades now. So something to kind of call out. And then the final thing, something to kind of read, again, not important for the exam, to be honest. But this idea of the version skew policy for Kubernetes. So if you're managing Kubernetes in production and you're planning on doing an upgrade, basically what the skew policy is about is what's the maximum version difference I can have both from my control plane components and for my worker nodes. And kind of the rule of thumb is you can have a one version difference between your API server. So you can have an API server running 1.18 and 1.19. And then for your worker nodes, there can be a two version difference. So like 1.17 and 1.19. But that's kind of defined in the version skew policy. Again, not important for the exam, but something to kind of know if you're managing Kubernetes for real. But I don't think I'm going to have a lot of time to go through this upgrade lab, and I kind of expected this, but there is a great lab on Catacota for using kubectl to perform an upgrade against a 2-node cluster. So a very small cluster, but it gets you familiar with the commands that you have to know. And there's realistically probably only 3 or 4 that you have to know to perform an upgrade using kubectl on your cluster. So if you want to walk through the path of doing a Kubernetes upgrade using kubectl, here's a link. Certainly give that a shot. A great resource. And then the next thing I'll kind of call out to, more Kubernetes documentation or Kubernetes docs information you can bookmark and look at before the exam, and memorize the location of going into the exam. So another link. So I don't know if the exam asks you to perform an upgrade, and I haven't taken the newest exam, so I don't know if it does or not. Just not breaking my NDA there, promise. So I don't know if it asks you to do an upgrade, but if it does, here's a link in the documentation that you can quickly reference and perform that upgrade. And again, it's a fairly straightforward process and something you can practice using Catacota. But updates was a final thing, but just some final thoughts and really a tip. So in a couple of weeks, I think it's in November, I'm going to be doing a full tips episode and kind of lessons I learned when taking these exams and some things to think about. However, there is one tip I want to throw out there that you should really be thinking about right now. And what that tip is start creating a bookmark list right now. And what I mean by this is one of the things that the exam allows you to bring with you, I'm assuming they haven't gotten rid of it yet, is a list of bookmarks like in your toolbar. So one of the cool things that you can do is like that upgrade article I showed earlier, make a bookmark for that and put it in your toolbar. So when you go into the exam and you use your Chrome browser to take the exam, the bookmark's already there for you and you can immediately click on it if the exam asks you to do an upgrade. Again, I don't know if it asks you to do that, but you'll have that link to perform that upgrade. And that is a significant time saver. I did not do bookmarks for the CKAD, the CKA and CKAD. However, I did one for the CKS, and I was down to the minute on that exam. So these bookmarks saved me. So the reason why I say start creating your list now is, you're probably going to run into articles that you will need during the exam. And it helps to bookmark those and make note of them now versus, later on in the line or like the night before the exam, you're asking yourself, well, what the heck are all these articles that I used again? Well, now you have your list of bookmarks already pre-built if you start early and start creating this list early. So calling that out is a very important tip. Think about it. Start working on that list because, again, this is a great resource going into the exam. Yeah, it's fantastic. So there's my quick tip, and then again later on I'll have a couple other tips for the exam that you can use. And then one final thing I just wanted to talk about. So in the previous 2 sections, we've talked about resources that we've used to pass the exam. I have 2, maybe 3 resources I would encourage. So I brought up the Coopctl earlier. Again, this is something you can buy on Udemy. It's probably on sale every 2 weeks. Keep an eye out for a Udemy sale or just create a new Udemy account. Usually they give new accounts a sales price when you buy something new. So maybe you're able to cheat the system there, just calling that out. But this is a great class. This was how I was able to pass the exam. Fantastic. I mean, they cover almost everything that's on that exam. And then the second thing I would kind of call out is, let's say, for example, you're like, all right, I've gone through this Coopctl stuff. I still want the exam experience. I'm not comfortable yet. There's this site called killer.sh, and this is fairly new, but I did use this for the CKS. And what this gives you is a CKA exam simulator. So you can go through this simulated test environment and take the exam and kind of get the exam experience that way. And I would say that killer.sh has questions that are a little bit tougher, in my opinion, than the actual exam itself. So if you can pass killer.sh, you got a good shot in passing the real exam, in my opinion. So that's the second resource. Linux Academy also has a CKA course. I've heard other people talk positively about it. So if you're an organization that has a Linux Academy subscription, take a look at that. I think it's now part of A Cloud Guru. So that's another resource. And then I don't know. I'm trying to think if there's any others. Catacota, again, seriously, it is a time saver. You don't have to worry about setting up your own cluster. Use Catacota. It's just great. Honestly, like I'll give a quick example. Like right before I took the exam, like I had a random question in mind, and I can't remember what it was, but it was like, all right, what's the kubectl command to create the specific resource? And I could figure that out very quickly just by going to Catacota versus like spinning up my own cluster and I don't know, EKS, which is going to take me 15 minutes. Just use Catacota. It saves you a lot of time. But with all that said, that is everything I have for tonight. I appreciate everybody watching for the last hour. And again, if you have any questions, seriously, feel free to reach out to me. Tyler Hatton on LinkedIn, t@tyler.sh from an email standpoint. Always happy to answer questions around the exams. They're great exams to take. And yeah, looking forward to hearing feedback on other people's experiences.
Awesome. Yeah. Great content, great information and links. Thank you so much, Tyler. Really appreciate all of that insight and those tips. I think after this, I may have to ask you for a bookmark export. Just kidding, half kidding. But that's an excellent tip. Like, one of the things I was curious about from other people was, did you spend a lot of time going through the documentation to sort of learn how to navigate it, right? Learn where this section is, where that section is, so that when you were doing it. But allowing you to bring in bookmarks, that's amazing. So
yeah. Well, I'll tell you what I did for the CK and CKD is I actually memorized like the terms that I would put into the search to find certain articles. So that's the other way you can do it. If you're like, for some reason, if they ever ban bookmarks, which I don't think they have yet, but I could potentially see them doing that. The other way you can do it is like make a list in Notepad of the different search terms and what they map to. Like, I don't know, to get pods, search for pods. But you get what I'm saying. Figure out what the search terms are, and that's your index that you can use to navigate through the documentation. Because sometimes what you have to search for to get a specific example within the documentation isn't obvious. But the other thing I'll kind of mention too, at least when it comes to the documentation and why it's nice to have those bookmarks, is a lot of what I did on the exam is instead of like manually writing those manifests, I would almost always copy an example from the documentation and then paste it into the lab environment and then kind of tweak it for what I needed. So again, 2 hours sounds like a lot of time, but I can tell you that at least for the CKAD and the CKS, which were the 2 hour exams I took, it was 3 hours when I took the CKA. But for those 2 hour exams, like the questions aren't tough, but you're going to be strapped for time in almost every case. So any way you can figure out how to save time is certainly useful.
Yeah, absolutely. Well, we are a little bit, we're almost right on time. So let me take a look and check here. So
I saw that one message so around still no courage to take the exam yet. Maybe after your series I'll take the plunge. So one other word of advice I'll provide around the CKA is, and it's kind of I don't know, kind of called a fail safe or kind of a nice to have is, and I think this is still the case, you still get a free retake when you take the CKA. So if you fail that exam, you get a free retake with it. At least I think that's still the case. You might want to verify that. So what I've seen a lot of people do is, they're kind of in limbo, right? They're not sure, hey, should I take the exam? Should I not take the exam? I don't know. And one of the things you can do is just take it. And if you fail, you have that free retake. And, the next time you take it, you'll be super confident because you'll have a pretty good idea what they're asking for and you can go from there. So take advantage of that free retake. If you're in that limbo phase, take the retake. It's extremely helpful.
Yeah, that's a great point. Yeah. So SC, go out there and take it or check to see if the retake is still available and then go take it. But that's a great perk. I wish all certification providers would do that. Honestly, I think that would be very helpful because they're expensive, like $300. I mean, especially if you're putting that, yourself, you don't want to just go and you want to be prepared, right? Or at least I know I completely over prepare for those because I don't want to waste my $300, like however expensive the exam is. So SC, go out there, take it, learn your weak points and then try again. Or again, verify first that that's still the case, but awesome perk if it is. So I don't see any questions on the Twitter feed, but yeah, and I think I don't have any other questions myself. I think the panel or the participants don't. So Tyler, once again, thank you very much. Super informative. And thank you everyone for joining. And as always, you can watch this session on YouTube. We will be posting that in a few days and look forward to seeing you all next week for our next session. Take care.
Thanks, everybody.